So number 2, depending on your test, the one I have in front of me had tan of 3 pi over 16 divided by cotangent of 5 pi over 16 plus sine of pi over 4. And I asked you to simplify this, I think. Find the exact value. So how do you find the exact value of this? You guys got to do some studying before this quiz comes around. Yeah, so first you have to recognize that these guys are cofunctions, right? Tangent and cotangent, cofunctions. And then you have to recognize that these guys add up to pi over 2. They're complementary angles. So if you take 3 pi over 16 plus 5 pi over 16, you get 8 pi over 16, which is pi over 2. So these guys add up to 90, which means you have cofunctions of complementary angles. So these are equal. Once you know the top and bottom of a fraction are equal, that fraction is 1. Right? 2 over 2 is equal to 1. 5 over 5 is equal to 1. X over x is equal to 1. Tangent of 3 pi over 16 over cotangent of 5 pi over 16 is equal to 1. So then all you have to do is figure out what sine of pi over 4 is and then add these two. What's sine of pi over 4?
Square root 2.
Root 2 over 2, which you either get from your triangle or from your unit circle. And then you add these together. Unfortunately, this is a fraction, so I'm going to put this over 1 and try to get a common denominator, multiplying by 2 over 2. So 2 over 2 plus root 2 over 2 is 2 plus root 2 over 2. Answer D.
And then the top of the building, you have to say to the bottom of the building, so I'm just asking
yeah, but
that wording.
If you read the whole sentence instead of just that phrase of the sentence, you notice that the sentence is talking about an angle of elevation. Joe measured the angle of elevation. So when I say from a point 100 feet away from a building to the top of the building, I'm describing the angle of elevation.
Oh, okay, so that was the 55 degrees then?
That was telling you, number 3, it's, where it says, Joe measured the angle of elevation from a point 100 feet away from a building. So you have a building, Joe is 100 feet away from the building, and he's measuring the angle of elevation to the top of the building, 55 degrees.
So when you said that, I should have been thinking about the 55 degrees, not how much distance.
Well, yeah, I mean, you should have been thinking about the subject of this, this guy right here, the angle of elevation, right? Because the angle of elevation between, from what to what, between what and what. I mean, so I have to somehow describe what this angle of elevation is between. But I understand. So I understand that hard wording for someone.
It's a little tricky.
Could you just go over the last identity one? It was the secant squared minus cotangent squared minus tangent squared plus cosecant squared.
I don't know if this is the same one as yours, but this is the one I have. Cosecant squared theta minus tangent squared theta minus cotan squared theta plus secant squared theta was the problem, and I asked you to use identities to find the exact value of the expression. So you kind of, in order to really be successful on this problem, you have to know your fundamental identities, your Pythagorean identities actually, which say, the first one is sine squared plus cosine squared. So sine squared of theta plus cosine squared of theta equals 1. This is your first Pythagorean identity. If you divide all of these by cosine squared, and if you divide all of these by sine squared, you get a different Pythagorean identity. So for example, if I put a cosine squared on the bottom here, like this, so sine over cosine, this guy's going to give you tangent squared. Sine over cosine is tangent. Plus 1, because this is 1. 1 over cosine is secant squared. So this is the guy that's really going to help you with part of this, because you have tangent squares and secant squares in there. The other one you need is to take sine squared theta plus cos squared theta equals 1 and divide it all by sine squared. So this gives you the other important identity here, which is that 1 plus cosine squared over sine squared is cotangent squared. 1 over sine squared is, this is the other important identity. Now once you remember these, there's still a couple of ways to proceed through this problem, and it kind of depends on how you analyze it, which way you go. One way to go is just straight substitution, meaning that you know that secant squared is tangent squared plus 1. So one method to help simplify this is to take this secant squared and replace it with tangent squared plus 1. What that does for you is it gives you a problem where you have a tangent squared and a tangent squared, so now you can combine it. And you can do the same thing with cosecant squared. Cosecant squared is equal to 1 plus cotangent squared. So in place of cosecant squared, I'm going to get rid of it and substitute in 1 plus cotangent squared. Everything else, the other two things, I'm going to leave the same. And then I'm going to collect like terms. You have a negative tangent squared and a positive tangent squared. Those are 0. Because they're the same thing, but one's positive and one's negative. If you have a positive cotangent squared and a negative cotangent squared, those are 0. So all you're left with is 1 plus 1. So this is one method. It's maybe a little longer, but I think it's a little bit easier to process if you're new at this. Right? You take secant squared and replace it with what you know it is. You take cosecant squared and replace it with what you know it is. And that'll get you your. The other way to do this is you can start back from the beginning and kind of group these in a little bit different fashion. Because tangent squared and secant squared are related in one of these identities, I would group this tangent squared and this secant squared together. And because cosecant squared and cotangent squared are over here, I would group these two together. So you can think of this expression as cosecant squared minus cotangent squared by grouping those together, and then you do plus secant squared minus tan squared. How does that help me? What does that matter? And what's cosecant squared minus cotangent squared equal to? 1. Why?
Because you changed the...
Right here in this formula, if you subtract the cotangent squared over, you can get a new sort of equivalent identity. Right? If you subtract the cotangent squared to the other side, you know that 1 is equal to cosecant squared minus cotangent squared. Let's subtract this over. So up here, I know this is just 1. Same thing on this guy. If I subtract over the tangent squared, secant squared minus tangent squared is just and if you add those up, you get 2. So on Wednesday, I'll give you some review problems on a quiz, and you take 15-20 minutes and do them, and then move on. For now, I'm probably going to start the new stuff, 6466. Anything else? Yes, sir.
Number 6 in the one physics,
Use the given value and properties of trig functions to find sine of 2 pi minus theta. So depending on your test, it's changed a little bit, but on this test I'm looking at, I have sine theta equals 3/8, and I wanted you to tell me what sine of 2 pi minus theta equals. How do you do this and why? Okay, so what's sine of an angle plus 2 pi? This is 1 revolution past this angle, so you're going to land at the same spot on the unit circle. If I'm graphing this, just for logic's sake here, here's theta, and if I go plus an extra 2 pi, that means I go theta and then another full revolution, which means I get back in the exact same place. So whatever sine of theta was, it's going to be equal to sine of theta plus 2 pi because it lands you at the same place on the unit circle. You have the same y value. So these are equal. But it doesn't matter whether I go a full revolution in the positive angle direction or I go a full revolution in the negative angle direction. Although this is actually plus 2 pi, so maybe not going to do it that way. So this extra 2 pi is not going to matter. It's going to be the same thing as sine of what? Theta or negative theta? Negative theta, yes. The 2 pi you can drop, the negative you can't. Right, this 2 pi, because in front of the 2 pi is a positive, this is like an extra full rotation in the positive direction. If you drop that, you'll get the same thing. But if you drop the negative, you'll get something different. What happens with negatives inside of sine? The negative inside of sine can be pulled out by what we call the even and odd properties. Right, the idea is whether you're up here at an angle of theta or you're down here at an angle of negative theta, the y value on the unit circle can be calculated, and what will be the difference? A negative sign. So when you plug negative theta into your sine function, you get out a negative answer, the negative of the original. So this negative can come out in front. Now that's different with cosine, right? If you plug in, if you're looking at the cosine, cosine is the x value. Cosine of theta or cosine of negative theta are the same thing. So kind of the rule is, in general, sine of negative theta is equal to negative sine theta. But cos of negative theta is equal to what? Just cos theta. You might as well not have plugged in the negative because you have the same exact x value. So in this case, my answer is going to be negative sine theta. I knew sine theta was 3/8. So it should have been negative 3/8. Whatever answer that.
Can you do number 4 with a comma?
4 on the multiple choice gave you clock problems. Through what angle measure does the minute hand of a clock rotate? And this one it says between 5:10 and 5:30. I think I did 3:05 and 3:25 maybe for the other one. All right, but you have to picture your clock. I would probably make my 5-minute markers. Right, so 1, 2, 3, 4, 5, 6. So here's my clock. I'm going from 5:10 to 5:30, and I'm focusing on the minute hand. So at 5:10, this is the minute hand. And at 5:30, this is the minute hand. So the whole question is, what angle is this? Do you know? There's a couple ways to do it. If you have a good enough picture, you can probably just eyeball it. But one legit way to do it would be to say you've taken a half circle right here. This half circle, what's the measure if I go from, 5 o'clock to 5:30? What angle is this? 180 or pi, right? So I've taken pi, I've cut it into 1, 2, 3, 4, 5, 6 equal sectors. And I've gone 1, 2, 3, 4 of those sectors. So pi over 6 is how far I go if I just move 5 minutes. Because I've gone 1/6 of the way around a half circle. But because I went 4 of those, I've gone 4 pi over 6, or I guess negative because we're going in the negative angle direction. And that's negative 2 pi. So one way that I do it, because I'm visual, is I say, well, I know half circle is pi. How many sectors have I cut pi into? I cut pi into 6 sectors, and how many of those have I gone? 4 of them. There's other ways to do it. How else could you do this?
Can I just do 3 sections? Because you're going, on mine it was going by 10, so it was 5, 10, and 5:30, so just divide it 10, 20, 30.
So you can divide this into 3 equal sectors. That would work. Right, here's 1, 2, 3. You went 2 of the 3 equal sectors. Does anybody do it with ratios or proportions? That's too smart for you? Okay. You can probably set up a proportion like, that in 60 minutes you go 2 pi radians, right? Because that's 1 full revolution. And so then you can set that equal to 20 minutes over x radians. And solve for x. That's another way to do it. This will give you, when you multiply this up, it'll be 40 pi, and when you bring this down, it'll be 60. So 40 pi over 60 will be 2 pi over 3 again.
Also, when it says through, does it mean to that one? Because I thought that it just meant an angle that it was in between the angles that it was going to. So, that would be 2 pi over 3. I mean, negative 2 pi over 3, but the angle that was in between them would be the one, because it's a through. But it means to that angle, right? Like, for example, there it would move through the 3, but it's not. But that's not the answer, so therefore.
I understand what you're saying, but I don't. To what angle measure does the minute hand of a clock rotate? You rotate through an angle. You don't rotate to an angle because that's assuming that this is the angle, but this isn't an angle. This is the terminal ray of the angle. So to what terminal ray?
Oh, okay.
No, I don't know how I could phrase it like that. Path. excuse me, past which angle does it rotate maybe would be more what you're thinking. But no, it's true. Also, this is just like, it's meant to be just like the question we're doing after this. So if you take the test with me, you're absolutely more than welcome to ask me those kind of questions. I know you didn't take it with me, so you're at a slight disadvantage. You'll survive.